Hello, 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 everybody. Good morning. It's a beautiful morning here in California. My name is Nicholas. I'm a data scientist at the Pragmatic Institute, and I am very excited to talk to everyone today in Unit 1, office hours for Unit 1. This is very, very exciting. So, how is everyone doing this morning or this evening? I know that in other parts of the world it's night. So, just how is everyone doing? I see Srikanth is doing great. I'm glad to hear it. Jahangir is also doing good. Anyen is good. This is great. Tiger's good. Everyone is here. It's good to see some familiar faces. Gebrense is here. Changyen, excellent. Changyen is learning English and programming at the same time. That's incredible. Wow, good for you. Javid is here. Philip is here. Excellent. I'm doing great, everyone. Thank you for asking. And it's finally Independence Day in Uganda. So happy Independence Day to all of our students and all of our friends in Uganda. And I see that Babatunde is at the TensorFlow Roadshow in Lagos. That sounds amazing. Excellent. I see Cote d'Ivoire is here. Wonderful. I see Kenya is here. Pakistan is here. This is great. Benin is here represented. I do, Gebrin say, I do remember. Of course. How could I forget? I'm glad you're back. So, what would you guys like to work on today? I'm going to pull up my, there we go, pull up my pad here. And I do see that somebody has already requested looking at the mini project. Okay. What else would you guys like to look at today? I see Zambia is here. Wonderful. Tiger, don't worry. We'll definitely get to the mini project. Wallace, happy Independence Day. Brian is saying hello to their coolest friends in the world. And we'll say, no, Brian, you're the coolest friend in the world. We're not going to get to Team Code. I see you're already on the CV mini project. We're not quite there yet, but we can definitely look at them. We can look at zip functions, and we'll look at x.self, or what is it, self.x, or excuse me. Okay. And we can certainly get started on the mini project for VC. Let's see where we are in terms of our onboarding syllabus. So we should be starting the VC mini project as well. Okay, great. And Charles says that they think that the mini projects are to help us apply what we've learned, and that's absolutely right. That's what they're here for. And we also need to do memoization. Okay, beautiful. All right, so what I'm going to do is I'm going to start with zip functions and memoization, and then I will move into the IP mini project, and hopefully then we'll have some time for everything else. If we don't start, if we don't start the VC mini project today, I'll make sure that we start it tomorrow. So let's get started. Okay, so first things first, I'm going to go to the home folder, and then I'm going to go to Python, and we're interested in Python algorithms. Now, when we were talking about algorithms previously, we talked about ways that you can speed up your algorithm by reducing the number of calculations that your algorithm needs to execute. So for example, when we were summing the numbers using this sort of factorial function, we originally did it with a for loop, which was complexity order n, and then we were able to we were able to substitute it with this Gauss formula, which actually is constant, O of 1, order 1. Now, the other way that you can actually, you know what I'm going to do? Yeah, I figure, okay, I'm just rearranging my battle plan in my head. Okay, so that's one way in which you can speed up a program by reducing the number of calculations that your program runs. Another way you can do it, though, is using the process called memoization. So I'm going to scroll down all the way to the memoization section here. And what is memoization? So memoization is very simply a way of saying, if I have a process that requires me to repeat something, maybe what I need to do is save some of those earlier results so that way I don't need to compute them again. I can just look them up. So instead of recomputing something, you just save that result for future use. And that is, in a nutshell, what memoization is. So let's just take a look at how that might work in practice. I'm going to run all above here. Give me 1 second, guys. I'm going to disappear for 1 second. I am back. Welcome, welcome, everyone. Good to be back. And while everything is just calculating, I think we're in the part where we're calculating all the different. Here we go. Beautiful. Okay. All right. Memoization. Oh, I see Putha is saying that they need the What's Up link. If anyone has posted it in the forum, please let me know so that way I can get it for us. I can share it with the group. In fact, I'll go to the What's Up link here. I'll search. And I see here we have a bunch of different groups. I have forming a WhatsApp group. I'll copy this link address. This is the global one, it looks like. This is for everyone. You guys tell me if I'm wrong. And then we have one for Uganda. So what better way to celebrate Independence Day than joining a data science WhatsApp group? And we also have Nigeria. And then finally, we have a study group for India. Now keep in mind that these are not affiliated officially with World Quant University. We don't monitor them. We have nothing to do with them. But you guys as students are free to make them if you want. Okay, so let's return to our function here. And the first thing that I want to do is I know that let me see if I can just orient myself here. I know that the way a Fibonacci sequence works is, and I'll pull up my board here. I know it starts with a 1, 1, and I know that I get the next number, n, by adding n. Let me see if I can. How can I put this? By adding the two previous numbers. So I know that the next number here is going to be 2, and after that I know it's going to be 3, and then I know it's going to be 5, and so on and so forth. Now, the thing here is that if I'm going to do, let's say I'm going to look at 5, the first 5 sequences here, I know I'm going to go 3, 5, and then I'm going to move forward and forward, or 1, 1, 2, 3, 5. And you can see here that we are, if I do this with n of 25, you can see that I'm doing this multiple times. There are many cases where I'm calling the same number and doing the same addition over and over again. And so what I could do is if I store the answer, that is to say, I create a dictionary and I store the answer, instead of moving forward and recalculating, I can see that my memoization is in terms of nanoseconds, and my recursive function is like a second and a half. Let me change the screen. Sorry, everyone. Sorry. So what I can see that is if I have a dictionary and I create a dictionary whereby I am storing my answers as I make them, I don't need to recalculate. And that will save me lots and lots of time. I mean, it's an orders of magnitude better. So that's the basic idea of memoization. Instead of calculating something over and over again, you can store the result in, for example, a dictionary. And before calculating anything, you're going to check and see whether your number is in the dictionary. So that's memoization. Does anyone have any additional questions on memoization before we go to the mini project? So Srikant has a question, which is, in what cases do we use memoization? And memoization would be for cases in which you're performing the same calculations over and over again. So if you need to reuse numbers or reuse calculations, that's the way to do it. And memoization in data science, particularly, I see that Srikant is asking a question about when it's useful in data science. Really, anytime you find that you might need to use the same result twice. For example, I remember that I built a model that was about predicting temperature in lots of different cities, and I would store the different models to predict temperature for each city basically in a dictionary. And so that way I didn't need to retrain every time. I would just go to the city, look it up, get my result, and come back. Now, Somto has a really interesting question, which is memoization the same thing as a function? And the answer is no. It's a strategy that you would use when creating a function. So, for example, here in our Fibonacci memoization function, in our Fibonacci function, memoization function, the object that's doing the memoization is this dictionary right here, this dictionary. And it is storing all the numbers. So for example, if I go to, let me open up a new cell here, and I'm going to go Fibonacci memoization, and then I'm going to also, let's see here, I'm going to do 33, and I'll pass it the first few values. Okay. And let's see here. The other thing I want to do is, let me think how I want to do this. I want to return. Let me think about it. I have to think about this for a second. I'll return this and then, okay. So I'll do print D. Okay, great. So let's look at how this works. So the way that this works is I'm adding a print function just so we can see the dictionary as it's being built. So what we can see here is every time we're getting to a number that isn't in the dictionary, it's adding it to the dictionary. And so by the end, the thing that's doing the memoization is this dictionary. Now, I see a question in the chat, which is in reference to databases, how does memoization apply? Memoization is sort of like creating a mini database within your function in this case. In this case, our mini database, or where we're keeping all our information, is in this dictionary. And Anthony has a really good question. They say they don't understand how the dictionary creates new indexes. Well, let's check it out. So the first thing is I start by checking. I have a dictionary, so I pass in my number n and I pass in d. And d is this dictionary that starts with just 0 and 1. And the first thing that I do is I check. And I check if n is in d. So if 10 is in my dictionary, I just return it. If that isn't the case, then I check whether it's 0 or 1. And these are keys. These are keys, guys. Keep in mind that these are keys. And if it's not 0 or 1, then I do my little recursive call where I look at Fibonacci memoization -1 and add it to Fibonacci memoization n minus 2. So I would look at Fibonacci memoization 9 plus Fibonacci memoization 8. And then once I finally got my answer, I would then store it here. And it creates the key because it knows what n is. I have my n, and then it stores the answer as, well, the answer. So for example, in the first iteration of this function, it stores, it creates a new entry under the key 2, and then stores the answer as 1. And in the next iteration, it stores the key 3 with the answer as 2. And actually, I wonder if we can do it just like this. Yeah. So let's go over about how this works. So let's start with just 1. I'm going to pass in 1 and an empty dictionary. So what's going to happen in this first iteration? It's going to have an empty dictionary in n, and then it's going to check and see if there is a key in the dictionary for 1. Now, because the dictionary, I see here what we're doing here. I see that there's some confusion. So let's keep in mind, I'm just going to make this a little bit easier to read, okay? So I'm going to change n to number and d to dict underscore. Okay, and d will be dict. And I'm doing dict underscore so that it doesn't clash with the dict object in Python. And by the way, guys, if you see that my screen is blurred, you might need to change the resolution that you're streaming at. Okay. So what happens in this function? I pass my function two things. I pass it a number, and I pass it an empty dictionary. Now, in my first iteration, if I'm just doing Fibonacci memoization 1, the first thing it's going to do is check and see if 1 is in the dictionary as a key. If it is a key, it'll return that answer. In this case, that won't happen because the dictionary is empty. And so what will happen is it'll go to this elif statement, and then it will say if number equals 0, the answer is 0. That's not the case, so it'll go to the next statement, elif, so if number equals 1, the answer is 1. So the answer is 1, and then it will skip down to the third to last line, and the first thing it will do is it will create a new entry in my dictionary with the key 1, and the value will be 1. And then it'll print the dictionary, which is what we see here, and then it'll return the answer, which in this case is 1, and that's what we see here. So that's what happens in this function. If I put in as my arguments for the number, I put in 1 and an empty dictionary. If I put in 2, we're going to see a couple different steps happen here. And I'll just do this last version and then we'll move on. Because basically once we get this second version, the whole rest of the process is like that. So I'm going to put in my Fibonacci memoization, and instead of 1, I'm putting in 2. And I'm putting in my empty dictionary. So in the first iteration of this function, it's going to check and see if 2 is in the dictionary. It's not because the dictionary is empty. So then it will go to the next elif statement, and it will check and see if the number is 0. It is not 0, so it'll skip it. It'll then check if the number is 1. It's not, so it'll skip it. And then it'll get to this last else statement, which means that we get to this part. And what happens here is now I'm calling the same function again. So this is recursive. But in this case, I'm doing Fibonacci memoization minus 1. So I'm doing Fibonacci memoization 1, the number 1, plus Fibonacci memoization 0. And then this whole process will run again. So the first thing that will happen is that this will be run. So it'll do this first part of the statement again, and that's where we get this dictionary. So it'll put a 1 and a 1 into the dictionary. And then it'll do this part of the statement. And that's why we add a new key to the dictionary. We already have 1, but then we add 0. And once I have 1 and 0, I can add them together. So I get 1. Now I'm back to my parent loop. And I know that for 2, the answer is 1, so I add that to my dictionary, and that's the last iteration of this cycle. And then I return my answer, 1. Now, a good question here is, because we're doing memoization, does it mean that recursion needs to be a part of what you're doing? I would say, I'm trying to think about this. I would say generally either recursion or some sort of iteration, some sort of for loop. It doesn't always need to be recursive, but there needs to be some sort of repetitive action. And Apurva makes a really good point, which is if I need to call again Fibonacci 1, I get the same thing, I get the same result, and that's true. But there's one big difference, which is if that if this key and value pair is already in my dictionary, I don't need to do the calculation. I can just look it up. So instead of having to do anything down here, I only need to do this. So if it's already in my dictionary, I save all these lines of code and I only run this part. And Siraj is right. Memoization is about preventing redundant calculations. That's exactly what memoization is, in a nutshell. Beautifully said, Siraj. So, just to summarize, well, basically to say what Siraj said, memoization is about preventing redundant calculations by storing calculations somewhere, often in a dictionary, so that instead of recalculating them, you just look them up. And so that's going to be a lot quicker. Beautiful. Okay. Thank you everyone for all your help on figuring out memoization. I'm going to close this window and then I'm going to go to my Okay, everybody. I'm back. I'm back. Hi everyone. I'm back. Good to see you all. I'm not sure what happened, but the good news is that I'm back now. All right. So, I'm going to go back to mini projects. And from there, I'm going to click on the IP mini project. And I'm going to scroll all the way down to where we were when we ended yesterday. All right, we were here at number 5. Now I'm going to do run all cells above. It'll just take 1 second. Thank you everyone for bearing with me during that technical issue. I'm not sure what happened. My stream just kind of cut off, but we're back now. Now, the whole idea of the Eratosthenes sieve, Aristophanes, I think that's, I don't know, my Greek is not very good, all right, is that I'm going to start, it's going to use a little bit sort of the memoization techniques that we talked about, where I'm going to have a list of numbers between 0 and n. And I'm going to mark some of them as prime. And I'll start with marking 0 and 1 to be not prime. And then I'm going to start with 2. And then what I'll do is I'll mark, that's my first prime. And then what I'll do is I will take all of the numbers. I'll start with that p and I'll multiply it by all of the n's to be not prime because I know that they're multiples of 2. So I'll mark 0 is not prime, 1 is not prime, 2 will be a prime, but then everything that's a multiple of 2, 4, 6, 8, 10, I will mark those as not prime. And then I'll repeat the process. So I'll find the smallest number that's greater than p. So in this case, I might start with 3, and then I will repeat the process. Now there are a bunch of different functions that we need to set up. The first thing is we need our list true function, which is going to make a list of all the values between uh, basically all the values up to and including n. And then we'll do the mark false function. And so it'll mark all the elements false if they're not prime. And then I'll have to find the next, find next. That'll be my next step, to find the next smallest one. And then I'll return a list where the values are true. So let's kind of just jump right in. Now, let's think about this for a second. If I want a list as true, what I want is, let me create a new number here, or a new cell. What I want is some sort of list. And I'm going to start like this. Whatever I do, let's say my n is 4. What I want to end up with is something that looks like this. Something that looks like this, where I have false, false for 0 and 1. And then everything after that will be set to true to start. Now the question is, I want to be able to pair the number 0, 1, 2, 3, etc. with it's either false or true, these different Boolean expressions that I have here. So I want to have a 0 here, I want to have a 1 here. I want to have a 2 here, a 3, whoops, a 3, and a 4. Now, what do you guys think? How can I do this? Now, Hari has a really, really good point. The answer is I don't need to do this because this information is already in the index. The first false here is already associated with the number 0 because, because it's the index place for that Boolean expression in the list. Now, Tiger's right. I could create a dictionary. Absolutely. That's definitely possible. But in this case, I don't need to do anything because the information is already here. I know that the first false is associated with 0 because it's at index position 0. I know the second false is associated with 1 because it's at index position 1, and so on and so forth. So the question is now, how do I create this list? If given the n of 4, how do I create a list that looks like this? What are some ideas that people have? So Hari's making a really good point. The length here is going to need to be 5 because it needs to include 0, 1, 2, 3, or 0, 1, 2, 3, 4. I see people doing some if statements. I love that idea. So Christiane is saying that we should do something with is prime fast. We're doing a new method here, so we can't use is prime fast. I like the way Charles is thinking. I'm going to write that down here. Charles has an idea of maybe I could just take true and I could multiply it by n. I could multiply it by n, excuse me, n plus 1. Let's just look at that here for a second and let's compare. Let's see what we have here. If I run this function and I do list true and I put in a 4, what I have here is 4 trues. 4 trues. So what I want to have is falses here. I need these first two to be false. So I'm close, but I'm not there yet. Now, Tanpan has another idea, which it could be true for I in range n plus 1. And I could do it this way. Now, this is a little bit faster because it's a list comprehension. But again, I have these trues here at the beginning. Now, Haneen has another idea, which is I could do two lists. I could start with false, false, and then I could add true times n minus 1. And you know what? That actually works. So this, I think, is a great solution. I'm going to share with you guys one more solution, which is basically this one, but as a list comprehension. So we'll give Haneen full credit for that answer. And I'm going to basically do a combination of Tan Phan's answer and Haneen's answer. So I'm going to have a list comprehension, and I'll start with I in range n plus 1. So that's what I'm iterating through. But instead of just putting a true here, I'm going to say I is more than 1. So what that means is that for 1 or for 0, it'll be marked as false. For 1, it'll be marked as false. And then for everything past that, it'll be marked as true. So this works. This looks great. Now, what's the difference between Haneen's answer and my answer? In terms of complexity, really nothing. It's the same. This one maybe looks a little bit cooler, but it doesn't matter. So I'm loving these answers. Oh, Yasir also has one which I encourage everyone to check out. That could also work. Yasir has this one here, which is, let's try this. I create false times n minus 2 plus true times n minus 1. Let's see if that works. Oh, wait, I need to make these capital. This doesn't quite work. It only works if n is 4 in this case. But as soon as I make it bigger, I begin to have problems. So I'm going to stick with my answer. Okay, good. So now that I have my list true, I'll do my assertions. And I get through my assertions, so that's good. And Kingsley has a question. They want to know if using a list comprehension is faster or better for time complexity than using a for loop. The answer is yes. Now, Jeffrey wants to know, what if I'm handling different alterations to the list? For example, false, true, true, false, whatever, whatever. And the answer is the purpose of this function is not to handle different types of lists. It's to create one specific kind of list, where if given a number n, it's going to create a list of length n plus 1, where the first two entries at index position 0 and index position 1 are false, and all subsequent items in that list are true. So that's all we have to work with. That's all we need to do. And Andrea, I see your question about I see your question. I will get to it. Don't worry. And Eric, I see you have your question about IntelliSense working with Jupyter Notebooks. The answer is no, but try using the Tab button when you're typing in a Jupyter Notebook, and you'll see that it will autocomplete. So if I just type in, for example, LIS, and I hit the Tab button, it'll give me all the options or all the variables in my namespace that start with LIS. Okay, so the next thing that I need to do is I need to do my mark false function. And in my mark false function, it's going to take a number, it'll take the Boolean list that is created by list true, and then I will give it a number, p, and then I need to find all the multiples of p and mark those in the list as false. So what I need to do is I need to iterate through that Boolean list and mark all the multiples of p as false. So for example, if I have list true, let's say 6, I'm going to go to, I'll start with 2. So this is at position 2. Actually, let's do it, well, let's go for item in, yep, list true. Actually, let's just keep it like this is. Actually, let's do for n in range list length. I'm just going to print something out so we can see it a little bit better. Print Okay, so here I just have a version of my list. So I guess I only need to do it like this, huh? Okay, great. So here I have a version of my list. And I see someone's getting a name error. Make sure you run the cell where you're creating your function. And what I need to do is I need to go through all these. So for example, if I start with 2, I would need to find all the multiples of 2, so 4 and 6, and I would need to then set these values from true to false, or here from true to false. So I see some ideas already, and I see that one idea that someone has is I'm going to do some sort of for loop. So I would do a for loop, and I would do maybe for I, because I'm thinking about index positions, and I would do a range, and I would start, I have P, so the next one that I need to start with is 2 times P. I need to go all the way to the end of the list, so the length of my Boolean list, and because I'm going 2p, 3p, 4p, 5p, the steps that I'm making are not steps by 1, they're steps by the distance of 2. So going back to this example, if I were looking at 2, my first index that I would look at would be index 4, which is 2 times p. And then my next step is I would take a step of 2. So I would go from 4 to 6. And that's the next one that I would switch to false. So what I would have to do is that for each of those steps, I would look at my Boolean list, and whatever was at that index position, I would set it to false. And then I would return my Boolean list. So you're right, I'm missing something here. Excuse me, guys. So for I in range, starting at 2p, up to the length of the list, and going by steps of p. Thank you guys for catching my typo. So let's just see if that works. So let's actually, I'm going to create a new thing here. So the first thing that I'm going to do is I'm going to go list true 6. So here's our list that we were first dealing with. And now what I want to do is I'm going to call this test list. And now I'm going to use my mark false function. And I'm going to say, take my test list, and my P will be 2. So what I'm hoping is that I'll get a new list that'll be like this original list with 2 important differences. 4, the value in the 4 index place will be set from true to false, and the value in the 6th index place will be set from true to false. Okay, and here I see that here what was at 4 is now false, and what was at 6 is now false. So that should get me through my assertion. Beautiful. Okay, it looks like office hours has come to an end. We're going to have to take a pause now. We've done our list true function. We've done our mark false function. And next, or tomorrow, I guess, we'll work on our find next function, and our prime from list function. So for those of you that are getting assertion errors or things like that, let me know. put them on the forum. Make sure that you post your code so that we can see and troubleshoot it with you. That's the best place to do it. For those of you that are looking for my notebook that we used yesterday, I'll put a copy into the shared folder. And for those of you that are interested in meticulous notes for today's class, I'm afraid I don't have those, but you can always watch this video and the links are going to be on your Jupyter Hub. So I'll see everyone tomorrow. I hope you have a wonderful afternoon, evening, day, wherever you are. I hope your algorithms are quick. I hope your memoization is working. And until we meet again, happy, happy, happy data science. Bye, everyone.